The next thing we need to talk about is another important subject, which is controlling access to what makes up our objects or our classes, controlling access to our properties and consequentially our behaviors. Okay, so going back to the essence of why do we even bother to do all of this? Why do we even bother to create classes, to have classes and compartmentalize all of these things, create small chunks of code that do one thing very well and inherit. Why do we even care about this? So always go back to the idea of why we do this. Why is it so important? The idea behind all of this is that we are trying again to compartmentalize our code to make sure that it's extensible, to make sure the code is into pieces that together work very well, okay, accomplish something. Going back to the idea that you could write an entire application in one file, very possible, but it would be a nightmare to maintain it, right? If there's an error or if there's something wrong, or if you want to work with other people in the same project, it will be just a nightmare. So that's just one of the main reasons why we are going through this, and why is it so wonderful to have an object-oriented programming language at hand, so that we don't have to worry about things that would bug us down as we start developing bigger applications. Okay? So back to the idea of a class, we said that a class has to be its own entity. It has to work as a black box per se. If you think of a car, for instance, you don't have to understand everything about, mechanically speaking, what a car does in order to operate it. In fact, I'm not a mechanic. I don't know a lot about cars, the internals of cars. In fact, I would say I don't know anything about how to fix a car, how a car really works, the internals, right? The motor and everything that makes up, okay? And so, but I don't need to be a mechanic to operate a car. And why is that? Well, the reason is because a lot of the hard stuff per se, right? The car in itself, or the motor or the engine and all this stuff, it's all abstracted out. It's all closed in somewhere where we don't have to see it. But we understand that the car moves, the car takes us places, allows us to start it. If you hear the word car, you never really automatically think of all these small components that make up a car. You just think as one entity. However, if you were to talk to a mechanic, he will have a different answer, a different perspective of what a car is. He will start talking about wheels, he will talk about steering wheels, he will talk about the engine and different kinds of engines. He will talk about a lot of different things that you had no idea, or maybe you had idea, but it's not necessary for people like us who just want to drive a car to know. That's the same idea we have when we learn about Java or object-oriented programming, is that we have to abstract away the intricate part of how things work as we build applications. With that in mind, each piece of what makes up a car is its own entity. Think of it as its own class. Okay, an engine, it's its own class, for instance. Okay, and the electrical system of the car, it's another class. But those two things are so separate, but they need each other in order to make up a car. Okay, so now when we talk about controlling access or access modifiers, we are trying to say, well, as we create these classes and instantiate objects, they have to communicate with each other somehow, but they don't have to be all over each other to where they can destroy the whole system, the whole ecosystem. Here we have ball, our main class, parent class, and we have public, string, and all of that stuff, okay? Now let's do a quick example here. What if I said, let's add, for instance, here, let's say public int capacity, just capacity. This capacity is just the capacity of how much air this ball can withhold. Okay, so let's save this. So if we go to main here, if I say my ball, there it is already, right? So if you don't have this my ball instantiated, go ahead and do that. So we have my ball here. If we say my ball dot capacity, and we give it 10. That's wonderful, right? We go here, get rid of all of this. In fact, let's just go ahead and do that. Say system, new system, that out, print ln, say my ball, that capacity, save, we should see 10. Okay, 10, and it says basketball, doesn't matter. Just look at this number here, 10. Perfect. So we have that there. The ball capacity is a very important property in the real world sense of thing, because this tells us what a ball really is. Now, if you think a ball as this round thing that withholds air inside so that it can bounce and be a ball, what if we go back here and say my ball at capacity is 0? If we run this, it will work. No problem. It's going to be 0. But I have a question for you. Does this make sense if I say ball capacity is equal to 0? If you think of a ball in the real world and its capacity, meaning that the ability for it to withhold a certain amount of air is 0, what kind of ball is that? It makes no sense in the real world. In programming here, it's fine, it's great, but it makes no sense. And since we are, when we create these applications, these classes, we are emulating the real world thing, then it's safe to assume that this makes no sense. Therefore, this is a big no-no. So what's happening here is that we are able to access certain properties of our main class here outside of the actual class. Because here, we're not inside of a ball. We are inside of our main.java, where we are able to call this capacity here. You see the problem now? Now we are giving this main here, this main class, power that it should not have that power, because now we can do a lot of things here that it's not really good things, because that will just destroy a lot of other parts of this whole ecosystem that we're trying to build, if that makes any sense. Think about it. If we, for instance, this ball, if a lot of different classes depended on the capacity of my ball being greater or bigger than 0, this would have destroyed the whole ecosystem, because there's just this one variable that was set to 0 and was not supposed to. Now, you can say, well, I could have put an if statement there. Yes, that is very valid, but that is just not good. Right? Because we want to make sure that when we create our variables, our instance variables, we have a way to protect certain properties that can only be seen or changed inside of our class, because that's the idea, having a class that does all of the work, has its own properties, manipulates all these properties, and has its own world. Okay? And this is why we have to be able to control access. In this case, all of these, if you notice, they are public. If we have public anything, that means anybody can go and access it. Okay, so what we're going to learn right now is a few things. We are going to learn a few access modifiers here. The first one is going to be public, which you already know. So anyone can access. The second one is going to be private, which you're going to learn right now. Only accessed within the class. Okay? So in the next video, you will learn about how to use the private keyword so that we can protect our instance variables. All right, so I'll see you in the next video.